This is the review of test number 3 to help you with the retake. So the first question asks us to look at the graphs of 1 over x, which is this one, and the g of x graph, which is 1 over x squared. That's that one. And then we need to decide which characteristic belongs to which graph. So if we're talking about whether graphs are even or odd, even graphs you can fold in half like a butterfly on the y-axis, and odd graphs look the same if you spin your paper 180 degrees. So if we look at the first graph here, f of x you cannot fold it in half on the y-axis. It will not look the same. However, if you look at the graph now and you spin your paper 180 degrees, the graph looks the same. So this first one is an odd graph. If I look at 1 over x squared, I can fold it in half on the y-axis and the lines match up, they're the same. So this graph is even. So the g of x graph is even, so you write g of x here. The next question asks if the graph has a horizontal asymptote of the x-axis. So horizontal asymptote is this way. Remember, an asymptote is where the graph cannot touch. So if I look on the first graph here, does the graph touch the x-axis? No, so that means that there is a horizontal asymptote of the x-axis. The same with here. It's getting very, very close, but it does not cross it, does not touch the x-axis. So both graphs have a horizontal asymptote on the x-axis. Next question talks about the domain. The domain is the x values. Are the x values of the functions all real numbers except 0? So if I look at this graph, all the x values are being hit except at 0 there's an asymptote. So that is true for 1 over x. And same here. We have all the x values except 0, and then all the x values again. So this one is also both. Now for the range is the y values. Are the y values of the functions all real numbers except 0? So this graph goes all the way down to all the way up, but it does not have anything at 0. So definitely f of x works. G of x, it doesn't have any negative numbers. So it cannot be all real numbers. So this one right here is just f of x. For page 2, the number of hours that it takes to bike 18 miles varies inversely as the average speed in miles per hour. The relationship is given by the formula h equals 18 over s. How long will it take to bike 18 miles, so the 18's already here, if his average speed is 5 miles per hour? So speed is 5, so we're going to plug in 5 where the s is. And you can use a calculator to help you. I get 3.6. And it says how long. So this is going to take 3.6 hours. Now I would like to wait to answer question B until I have graphed it. So once again, you might need to go to desmos.com. So for Desmos, we're going to type in y equals 18 divided by x. And it's hard to see the graph. You're going to have to zoom in some. Okay. Let me see if I can make it bigger. There we go. Now the sketch that they want me to use only is in that first quadrant. They only want me to use this part of the graph. So I think you can go to a table. So if you go to settings, you get a table here. And they only give us a couple numbers, but you can see that 1 is 18, 2 is 9. I can type in 3 is 6, 4 is 4.5, and you can keep going that way. It will plot all your points for you. And you're going to transfer those points to your graph. Okay, so we said 1 is 18. 2 is 9. 3 is 6. 4 is 4.5. 5 is 3.6. And you're going to have to keep going. I don't have enough space to show you everything. 6 is 3. 7 is 2.5. 8 is 2.25. 9 is 2. 10 is 1.8. It keeps getting closer and closer to 0. So if you keep hitting enter on Desmos when you're under the table, it will actually keep going down and you can see the numbers getting closer and closer to 0. Okay, so when you graph this, you connect all your points and just make sure your graph doesn't cross 0. Okay? So as the average speed increases, so as my graph goes out towards infinity, what is happening to the number of hours? Well, the hours get closer and closer to 0. So we can say the hours decrease. And get closer to you can use the word approaches if you want. That's page 2. Page 3, we're writing the equations. These are like the transformation problems that we were doing. Just to remind you, we start with 1 over x. Now, if we have a number, say plus some number here, you do the opposite. And that is the vertical asymptote. Now, if there's a number added to the outside, you do not do the opposite. It's whatever thing is there, and that is the horizontal asymptote. And now 1 over x looks like this, right? It's in the positive first quadrant. If you're doing a negative 1 over x, it would be in the other two quadrants. It flips places. Okay? So we can use all that information to make the graphs below. Let me see if I can highlight these. We're going to use the yellow to talk about the vertical asymptote. And hopefully you guys can see orange on orange. We will use the orange to talk about the horizontal asymptote. And I think the printer was a little bit off on this one. But we have the vertical asymptote at 2. And the horizontal asymptote is supposed to be at 0. It's just a little bit off with the printer. So for this one, we have 1 over the opposite of the vertical asymptote, which would be x minus 2. And then there's no horizontal asymptote, so you can write plus 0, or you don't need to write anything afterwards. For letter B, we have a vertical asymptote at 0 and a horizontal asymptote at 3. So my equation is going to be 1 over x plus 0 or minus 0. Either one's fine because it's 0. And then for the horizontal asymptote, we have it at plus 3. For the last graph, we have a vertical asymptote at 0, a horizontal asymptote also at 0. But what's different about this graph? Instead of it being in that first quadrant, like the rest of these, it's in the opposite quadrants. So it's going to be negative 1 over x plus 0 plus 0. Or you could just write it as negative 1 over x. The fourth page, we have a vertical asymptote going up and down at negative 2. We have a horizontal asymptote at 1. So we just need to explain, is Jill correct? So Jill says that the equation is 1 plus 1 over x plus 2. And you can imagine this 1 plus being on the other side, if that's easier for you to look at. Our vertical asymptote, remember, is the opposite of the denominator. And the horizontal asymptote is the plus 1. So is that what happened? So we need to say that the vertical asymptote, or the graph, I guess since we're talking about transformations, the graph moved left 2 because it is the opposite of what's in the denominator. The graph moved up 1 because that is what is being added to over x. For question letter B, they want you to take this expression and show how it equals this one. Okay, so to do that, we're going to use synthetic division. So you draw your box, you do the opposite of the denominator, the opposite of the denominator, you have -2. Then you write out the coefficients of the numerator. So the coefficient in front of x is 1, and in front of, well, there's no x there, so it's just 3. For synthetic division, you bring the first number down, and then you multiply. -2 times 1 is -2. 3 plus -2 is 1. So we get 1 and 1. This first one just is by itself because you need to do 1 less exponent than x. So if x is gone, it's just a number. And then the second one is our remainder. And the remainder goes over top of the denominator of the fraction. So yes, the equations are equal. We showed how they were equal using synthetic division. And when we finished, we got the equation at the top. And the last page. Question number 5 asks, is x equal 3 a solution to the equation? So if I take x equals 3, I'm going to plug it into one of the denominators. And technically you plug it into all of them, but you'll see why I'm just doing it for the first one here. So if I plug in 3 for x, I get 3 minus 3 equals 0. And you cannot have 0 as a denominator. So let me write x equals 3 is not a solution. Now to solve this equation, remember that if we get the denominators equal to each other, then we can cross them out. So the left side has x plus 4, but it's missing the x minus 2. So I multiply at the top and the bottom by x minus 2. The right side of the equation has x minus 2, but it's missing the x plus 4. So I multiply x plus 4 at the top and the bottom of the right side. Now, because the denominators are the same, you can get rid of them. And you're left with 7 times x minus 2 equals 5 times x plus 4. Now you'll have to distribute. And then we want to get the x's to one side and well, we're solving for x. So I'm going to subtract 5x on both sides. I get 2x minus 14 equals 20. Add 14 on both sides. You get 2x equals 34. Running out of room, so I brought it up to the top. Divide by 2. X equals 17. And the last question at the bottom here is asking for the least common multiple. Essentially, it's asking you to find the denominator. So if I look in the denominator here, I have an x minus 1, and an x. Well, these two denominators are the same, right? So this first denominator is missing the x minus 1. The second denominator is missing an x. The third denominator is missing an x minus 1. So if all the denominators are going to end up being x times x minus 1.